Okay, so today we are going to cover special right triangles. And there are actually two special right triangles. The first one is the 45, 45, 90 triangle. And then the second one is the 30, 60, 90. And there's a theorem for each. So on the next slide, it has the 45, 45, 90 triangle theorem. So we will use this information when we are given an isosceles right triangle. So if you notice, we have two 45-degree angles here. And then we can see that when we have two angles the same, this will also give us two congruent sides. Okay, so notice the two sides that are congruent are the legs of this right triangle. So when you have a 45, 45, 90 right triangle, the congruent sides are going to be the legs. Now, notice on the sides of my triangle, I have the letter A and I have a square root 2. So what this means is that if the two legs have a length of A, then the hypotenuse is going to be whatever the leg length is with square root 2 behind it. Now, one way that I remember, because when we see the 30, 60, 90, it's going to involve a square root of 3. And the way that I try to keep things so I can remember them is I notice that my 45, 45, 90 triangle has two angles that are the same and also two sides the same. So that's the one that gets the square root of 2. When we get to the 30, 60, 90, that has three different angles, and that one's going to get the square root of 3. Now, what's going to happen to you is I'm going to give you only one side of the triangle, and from that one side, you will be able to find the other two. So, for example, if in this triangle, I told you that A was equal to 8, then that would tell me that this other leg, which is also an A, is also 8. And then my hypotenuse is going to be whatever the leg is, which is 8, with the square root of 2 behind it. So this would be a type of question where I would just give you the value of A, and then from that, you could fill in the rest. Now, yes?
Can you do anything to 8 and then square root of 2?
No, you just leave it. Yes. All right, so let's go on to the next slide, and let's try an application of this. And then I'm going to add a couple more just so we can get the hang of this. So on the next slide, they're asking us to find the value of x. Now, if you recall from the previous slide, notice when I have two sides with the same variable, this should be a clue that these base angles are going to be congruent, and they're both going to be 45. So this is the 45, 45 right triangle. And again, if you want to use the same letters that are presented to you in the theorem, this could be A, this could be your A, and this is going to be A square root 2. Now, what's going to be very important in this lesson is that you understand how to work with square roots, with radicals. You're going to need to be able to add them, multiply them, and also understand how to rationalize the denominator. One thing that you should recall from Algebra 1 is that you can never leave the square root of any number in the bottom of a fraction. If that occurs, then you're going to go through the process of rationalizing the denominator. And that's what's going to happen in this problem when I want to find the value of x. So again, you're going to be given one side, and from that one side, you need to find the value of all the other sides. So if I'm given the hypotenuse, that the hypotenuse is equal to 6, and I know that the hypotenuse of a right triangle, especially a 45-45 right triangle, is equal to the a square root 2, I'm going to take this and solve this algebraically. So a square root 2 equals 6. I need to isolate a because that's what I'm looking for. So I'm going to divide both sides by the square root of 2. This will cancel. And now a is equal to 6 over the square root of 2. And like I just said, whenever you have a fraction, you can never leave a radical in the denominator. In order to get rid of that radical, that square root of 2, I need to rationalize this. And the way that I will rationalize the denominator is by making the denominator a perfect square. And the easiest way to do it is to multiply it by itself. Now, essentially, all I've done when I put square root 2 over square root 2 is I've just multiplied my fraction by 1. Because remember, anything divided by itself is 1. However, you don't need to know that, just understand the process here. So now, when I multiply an outside number by something inside a radical, I can't multiply outside with inside. So I'm just going to put them side by side. Then for the denominator, remember when you get a pair that's under the radical, that just comes out. Because the square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. But again, don't waste your time multiplying this. Just know when you multiply a radical by itself, the radical disappears and the number comes out. Now that I've gotten rid of the radical in the denominator, I can still simplify this fraction. I can simplify an outside number with something that's not under a radical. So 6 divided by 2 is 3. So the answer for x equals both of these sides, it's what a equals. So both sides are 3 square root 2. This is the worst case scenario when your hypotenuse is an integer, okay, when it's a whole number. Okay, it would be a lot easier if it had a radical 2 with it. So let me show you a few more examples of the 45, 45 before I move on to the 30, 60, 90. So let me draw in a couple x here. So let's say, again, I have some right triangles here. I'll do this one first. Now, sometimes your triangle would be labeled like this. Sometimes the sides might have congruency marks. Or sometimes they might even just give you the angle measures. All 3 of these triangles all represent a 45, 45, 90 right triangle. And again, the pattern you're going to memorize for a 45, 45 is that this side is A, this leg is A, and the hypotenuse is whatever A is, and then you put the square root 2 behind it. So let's try some examples. So let's say this time I told you that this side was 7. How much will this side be and this side? How much is x in my 45, 45, 90? These sides are congruent. So if that side is 7, this one's 7. How much is y going to be? 7 square root 2. So whenever you're given a leg as a whole number, the other leg is the same number, and the hypotenuse is whatever that leg is with square root 2 behind it. Let's try another one. Let's go over here to this triangle. Let's say I told you that this leg is 13. How much will this leg be? The x. 13. How much will y be? Nice. Okay, now we're going to go the other way. So now let's say instead, and again, I've got my 45, 45. Let's say this time I give you the hypotenuse, and I tell you the hypotenuse is 9 Square root 2. How much is x? Beautiful. How much is y? 9. Okay, the two legs, remember this leg is A. Oh, this leg would be A. This leg is A, and the hypotenuse is A square root 2. So if your hypotenuse has a square root of 2, then your A value is what's right here in front. So that's how I got 9 for this one and 9 for this one. Let's try another one. Again, they may label it with 45s. They may show that these two angles are congruent. Either way, this is going to indicate that this is a 45-45. So let's try again like the example I did from the note slide. Let's say that this hypotenuse has a length of 4. How much is x? How much is y? First of all, in terms of the a's, how much is what is the hypotenuse represented by? A square root 2. So now what I'm going to do is I'm going to solve this algebraically. Divide by root 2. This cancels. A is equal to 4 over the square root of 2. Again, I can't leave a square root in the bottom. I have to rationalize. So 4 square root 2 over 2. And again, I can simplify, and it becomes 2 root 2. So this leg is 2 root 2, and so is this one. So the three sides are 2 root 2, 2 root 2, and then the hypotenuse is 4. Yes. So, as Ashley just figured out, that there is a pattern to this. If your hypotenuse is a whole number, shortcut is divide it by 2 and put root 2. Okay?
That simple? Yeah.
It's that simple. Now, here's the problem. Okay? When people start looking for tricks, then they get confused when to use the tricks, because now we still have the 30, 60, 90. However, the example I just did is the hardest part of the 45, 45. So if you are good at, compartmentalizing and realizing, okay, for the 45, 45, 90, if my hypotenuse is a whole number, to find the length of the leg, divide it by 2 and put root 2. Okay? However, you should still understand the process of rationalizing. All right? So now we'll move on to the next theorem. And again, this number isn't important to us, but it does have a name, and this is the 30, 60, 90 triangle theorem. So here, the relationship of the legs, that in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. And the longer leg is root 3 times as long as the shorter leg. So again, like I said at the beginning, this one has 3 different angles, so this is how I can associate that this one gets the root 3. Now, they're using the words shorter leg, longer leg. If you recall back when we were talking about how to order angles from least to greatest or sides, remember the shortest side is always across from the shortest angle. So my shortest leg is going to be across from the 30-degree angle. The longer leg will be across from the 60. And then the hypotenuse is across from the right angle.
So the hypotenuse is the longest one?
Correct. Okay? Because 90 degrees is the biggest angle. All right. So let's add some numbers to this. So now, sometimes they're not going to label your triangle with all 4 angles, or all 3 angles, sorry. So for example, we might have a 90-degree angle and then a 30-degree angle. How could you figure out what that missing angle is? Exactly. Add and subtract from 180. Now, as soon as you see this, you should realize that these two angles, this one and this one, these are going to be complements. So really all you had to do was 90 minus 30 and you could get 60. However, you can add 30 plus 90 and then subtract from 180. So now let's practice this. So if the side across from the 30 is A, and if A equals 3, then the side across from 90 is 2A. So I would take what A equals, double it or times it by 2, and the side that is the hypotenuse would be 6. And now my side that's across from the 60, recall that is A square root 3. So I take what A equals, and then I put root 3 behind it. So you need to memorize that across from the 30 is A, across from the 60 is A square root 3, and across from the across from the 90, the hypotenuse is 2 times A. All right, so here is our first example. The missing angle, how much is it going to be? 30. Good. So I'll put a 30 up here. Now, the side that's across from the 30, what letter did we say that was? A. Good. The side that's across from the 60, what is that going to be? A what? Good. And then the side that's across from the 90 degrees or the hypotenuse? 2A. You see that okay? All right. So if A equals 5, how much is Y, which is 2A? 10. Good. So 2 times 5, and this one's 10. And then the side that's across from the 60, that X, how much is that going to be? 5 square root 3. Let me add a blank page. So let's draw a 30, 60, 90 here. Now, the 30 may not always be up at the top. It may not always be down here. So this is why you have to look at the numbers. So again, the side that's across from the 30, what letter is that? That one's A. What is the side across from the 90? Okay, across from the 90 is 2A. And then across from the 60 is the A square root 3. Everybody with me on that? Now notice how I switched the 30 and the 60. So now for this one, my A is over here. My A square root 3 is now down here. And then my hypotenuse is still here. Now I could also draw it backwards. Everybody with me how you can figure out where the A root 3 and the 2A are? You look for the angle across. All right. So now let's give these some values. So let me draw another triangle here. So let's say I'm giving you that it is a 30, 60, 90. And let's say that this leg down here is 5. How much is X? How much is Y? How much is it? Let's do Y first. How much is Y? Good. 5 times 2 or 10. I should do 2A. Let's do it that way. So this is equal to 2A. So 2 times 5, and it's 10. What is X? A square root 3. And what was A? Good. So this side is 5 square root 3. Good? Let's try another one. Let's say this time I give you, this is 12. How much is X? So what does 12 equal in terms of the A's? 2A. Good. So if 12, let me move this over a little. So if this is 2A and it equals 12, how much is A? 6, right? You divide by 2. So A equals 6. So this side was 12. Over here, across from the 30, this is your A, and it equals 6. How much is this side across from the 60? 6 square root 3, because remember, it's A square root 3. So sometimes I'll give you the hypotenuse, and it'll be an integer. Sometimes I'll give you one of the legs. Now let's go where I'm going to give you a different. I'll give you one of the legs this time. So 60, 30. And let's say this time I give you this side. Now, what might be beneficial is if you go through and say, okay, opposite 30 is A, opposite the 90 degrees is 2A, so then this one is A root 3. So what's A going to be?
7.
Good. What's 2A going to be?
14.
Perfect. Getting the hang of it?
Yeah.
All right, now I'm going to throw you a difficult one. Here we go. What if I told you this was 4? What side is that for? This is A root 3.
Oh.
It's across from the 60.
Oh, no.
Nope.
Okay? Remember, across from the 30 is A, and over here is the 2A. How can we find out what A is?
So you put 4 over 3 squared.
So I'm going to divide by the square root of 3. Good. So now, can I leave this square root of 3 in the bottom? No. How do I get rid of it? Multiply it by itself. Beautiful. So this becomes 4 square root 3 over 3. That is my value of A.
How did you know how to do a square root 3, or like 4 divided by a square root 3?
Because what you're going to memorize is that across from, let me put it like it is, across from the 30 is A, across from the 60 is A root 3, and this is 2A. So if I told you that the side across from the 60 equals 4, and if you memorize that the side across from the 60 is A square root 3, you're going to set up an algebraic equation and solve for A. And now, how do I find out what 2A equals?
Multiplying 4 square root 3 over 3 times 2.
Okay, good. So I'm going to multiply this by 2. What do I get? I'm going to multiply outside by outside, so 2 times 4, and I get 8 square root 3, and then I would do 1 times 3, and that just gives me over 3.
Wait, where'd you get 1 from? I'm lost.
I just took my whole number 2 and made it a fraction.
Well, shouldn't you multiply also the square root of 3?
Nope, I can only do outside with outside and inside with inside. So since 2 was outside of a radical, I can only do it with the number that's outside the radical. Yes.
So this is finding 2A.
Yes. So the value of 2A up here is 8 square root 3 over 3. Okay, so here it says the diagonal of a square has a length of 6. What is the perimeter of the square? So I'm going to, when you're not given a visual, I highly recommend that you draw yourself a picture. So let me go ahead and draw in a square here. Remember, a square has 4 congruent sides, and it also has 4 right angles. I'm going to draw in the diagonal, and it has a length of 6. Now, it doesn't matter if I draw the diagonal here or if I draw it up here. Just know that you need to draw in a diagonal, and it has a length of 6. Notice this diagonal has now split my square into 2 my diagonal has split my square into two right triangles. So let's say I talk about this top one or the bottom one, it really doesn't matter. So if I go ahead and take a look at this one, if this is a right angle and if these two sides are the same, this tells me I'm dealing with a 45, 45, 90. So whenever you have a square and you draw in a diagonal, it creates two 45, 45, 90 triangles. Now, if this diagonal, which is also the hypotenuse, is 6, how much are these legs going to be?
3 square, 2.
So remember Ashley's trick, she said take that hypotenuse, divide it by 2 and put square root 2. Now, if you don't remember the trick, then you need to take this algebraic equation and you need to solve for a. Divide by root 2, you get 6 over square root 2. We need to rationalize, and we get 6 square root 2 over 2, which then simplifies to 3 square root 2. Okay, now that I found the length of the leg, remember that is all of the sides of my square. So all 4 sides are 3 square root 2, because remember in a square, all sides are the same. Now this question did not ask us to find the length of the leg, it asked us to find the perimeter. So now, this is going back to adding radicals. I can find the perimeter 2 ways. I can either just take one of the sides, multiply it by 4, or I can take 3 square root 2 and keep adding this. Now,
Wait, what do you need added for, time?
because I'm asked to find the perimeter
Oh.
of the square. So now, when you add radicals, treat the radicals like a variable, and you only add outside numbers. So really think of this as like 3x plus 3x plus 3x, where x is your square root of 2. So this answer is going to be 12 square root 2. If you'd rather do this problem, you do outside with outside, and again, you still get 12 square root 2 for your perimeter. One more application. So again, if a picture is not provided, draw yourself one. So I'm going to draw an equilateral triangle. Now, remember, an equilateral triangle, all 3 sides are the same. Also, in an equilateral triangle, it's also equiangular, and each one of these angles is also 60 degrees. It's telling me that this equilateral triangle has an altitude, so I'll draw the altitude down, length of 5. So now, remember an altitude is always the perpendicular segment from the vertex to the side across. So now what I'm going to do is I'm going to work with only one side of this. So if I redraw this side over here, this is 90, this one's 60, and this altitude split that 60-degree angle to 30 and 30. So now this became 30 and 30. The side, that altitude, what is that equal to in terms of A? It's across from the 60. Good. So then the side across from 30 is what? What letter?
2A.
Okay, across from 30 would be,
Just A.
and then across from the 90 is the 2A. Everybody with me so far? So I think it really helps if you put in the A, the 2A, and the A square root 3, and then from there you're going to see what's given to you. All right, so now I need to find perimeter. So again, I'm looking for the hypotenuse. But in order to find the hypotenuse, I need to find that shorter leg, that a value. So I'm going to take what was given to me, this a square root of 3 equals 5, and solve for a. Divide by square root of 3, and a is equal to 5 over the square root of 3. Again, I need to rationalize. 5 square root of 3 over 3. This is my a value. To find out 2a, I multiply 5 square root of 3 over 3, and this gives me 10 square root 3 over 3. So that is my hypotenuse, which is also all of the sides of my equilateral triangle. So again, if I redraw the equilateral down here, this one is 10 square root 3 over 3. This one is 10 square root 3 over 3. And so is this one. So to find the perimeter, I'm just going to do 3 times 10 square root 3 over 3. Notice this time I could simplify diagonally, and the perimeter of my equilateral triangle is 10 square root 3.